Okay, how have you all been? I am in a strange mood because, as you can see my shared screen, right? So I was at an international conference on planning and scheduling systems for the last 2 weeks, except it was virtual. So I was in the conference the last 2 weeks, actually until 40 minutes back. Then I teleported myself back to this world. Physically, teleportation is very easy, but mentally it's quite hard. I'm not quite sure where I am. So this thing actually, how many of you know these things like Gather Town? So these days, it's basically called Gather.town. You can actually play with it. So Gather Town is this service where essentially, this is kind of a digression, but when COVID started, basically mostly in academic, in academia, people go for conferences, they write papers and travel somewhere and present them. And it started, I guess, at one time when the only way we can talk to each other is by being physically next to each other. And of course, then we realized that it's, for people in universities, that's a good way to see nice places. So we have conferences in some nice place. This one is supposed to be in Nancy, France. And so when COVID started back in March, then essentially all conferences got canceled. But then all the work in making a conference happen involves writing, all the papers getting reviewed, reviewing all the papers, and allowing people to present their work. So they had to find a different way of doing the whole thing. And so, of course, Zoom is one thing. The other thing that people have had is to kind of provide you a physical sense of where you are. These things like Gather Town, you'll have an avatar and then you can move it, using your game kind of a thing. And so these are all people, different people, right? I mean, they're all the people who are in the conference. And then what happens, one of the cute things with the Gather Town is when you go close to somebody, when you can set the radius of your microphone and camera. And when you go close to somebody, then their camera opens up, your camera opens up, and then you can chat. And all sorts of fun things. So in fact, these guys, so it's a Gather Town is like Minecraft, Minecraft, so you can build new things. So these guys actually built an entire separate thing. So they were feeling sad that we were not going to Nancy, France. So they made a hotel called Hotel, I guess, Place Stanislav. And so, in the Place Stanislav, there are like little chairs. You can sit on those chairs. And in fact, one of the cute things about the Gather Town is whenever there are chairs, if you sit on the chairs, that's when you are part of a private world. And so there are only 3 chairs there. So if somebody else wants to come, they can't join, except I just found yesterday, there are all sorts of, because it's all these are, computer things, they're all hacks. Like for example, you can ghost yourself and sit on other people's laps, which is very questionable, but I must admit that I wanted to join some group which is already full. So I hung around on somebody's lap for a while. And then once you do that, then you're part of the group and then you'll see everybody's canvas, etc. It's very strange in a weird way. You get adopted. The thing that's very interesting about humans is we get adopted to anything, so basically back in March, we did not think that this kind of a world will exist. Your kind of a world doesn't exist either. I mean, a class meant going to the class. Now we are all hanging around in Zoom. I'm also going to international conferences on Zoom, sitting in the same place. In fact, they had a group photo with all the people standing. That's why I wore my nice shirt and everything just for the group photo in the conference. And then I came back running to teach the class. Anyway, so that's where we are. So let's see. So what we are going to do are 2 things. So you all saw saw my mail, first of all, about the 3 blue, 1 brown videos. How many of you know of 3 blue, 1 brown already before? Okay. In general, you have to keep in mind, I mean, that guy is just amazing. So, to make one of those videos, you'll need a lot of time. But, clearly once he makes them, it's very nice to explain. The explanatory power of those videos is extremely good. I would definitely suggest things. I mean, he has like very nice videos on linear algebra. As and when you do linear algebra, which you will do in, many of you might do linear algebra in engineering and computer science, you might actually see, it's not that it's not a technically complete video, but sometimes you need to have an intuition as to what's going on before you can then start figuring out whether it makes sense technically. Okay. So anyway, that's why I thought I'll send you those and then get you to watch them. So my default plan for today is first, basically, we'll have whatever you want to discuss about based on the previous two classes. And then in terms of new material, basically what I was going to do is get a sense from you as to how many of you figured out what happened in those videos. If it's, some of you are very, not necessarily, and first of all, you're all freshmen, and some of you probably are not directly, in STEM direction. So if it was confusing, I am willing to just play it along right now and stop and then explain what's going on. The reason I want to do it is you all basically are showing up here because you want to talk about AI's effects in healthcare, AI's effects in bias, AI's effects in this and that. Currently, most of the data-based AI systems, use technology like that. So understanding a little, just a little, will help figuring out what people are talking about. It's not, again, it's still not an intro to AI course, but you need to have some technical sense of what's going on before we can make sense of what is happening right now within AI. Okay, so that's why I wanted to drag you through those. For some of you, probably it was easy. For some of you, it probably was kind of too far out of your interest. But again, if you want to understand AI, you have to understand a little bit about what the technologies are. It's not like you can't understand electricity without understanding anything about physics. At that point, only be understanding, yeah, there's a switch, and if you switch it on, that light will come on. That's the only level of understanding. So that's what I was going to do. Depending on what you want when we get there, either we can fast forward through that video in front of you, and I can actually play the video again in front of you, and then you can make me stop in various places and I can explain more things as needed. Or if everybody thinks they pretty much understood some things, then I can go assuming that you've seen and make some other discussion, do some other discussions about related to the technology, the neural network technology. That will lead us to things like that ostrich that I was talking about last time, the school bus with ostrich, etc. All of that sort of makes sense. So those of you who saw the video, you realize that at the end of the second video or something, he basically makes this whole deal about, okay, I'm trying to understand how to recognize numbers. And I'm assuming that the network tries to learn something like the way we recognize numbers, which is basically, a 4 will have like a line like this, a line like this, and a line like this. Okay. Except then when he actually figures out after learning, when he looks at what those internal neurons have learned, it is not at all like what we consider what makes something a 4. Do you understand what I'm saying? So given that, let me actually show you the picture. This is the picture that I'm mentioning, and we'll get to it. This is the one I was mentioning last time. So here is your school bus. Okay. I added some random noise. If you take an image is just a bunch of pixels. You know this, right? Because all of you know that you buy cameras and you think in terms of megapixels, etc., right? So I added noise. So a normal image would be like, basically the intensity values at each point. And actually, in fact, he looked at intensity values, between 0 and 1, but normally it can be between 0 and 156, 0, 254, 244, etc. There are different numbers in this grid. And those are the intensities for the image. And if you put the right set of intensities, then your eye sees, in this case, what you guys will consider as a school bus. Then I put a different set of intensities. You don't see anything here. It's just a bunch of noise. Okay. I essentially took, like, basically take this picture. I sort of multiply this picture by, let's say, 0.001 of this picture and add it to this picture. Do you understand adding pictures? So that means I'm sort of, for the matrix, numbers, let's say a number here, let's say if this number was like 77 and the corresponding number here was 44, then I'm basically saying 0.001 times 44 plus 77. That will be that particular pixel. Okay. Now I added them. You can clearly see that when I do this, essentially, I'll change the, if you basically, I mean, you played, you all know, like, if you go to Google Photos or Apple Photos, you can whiten images. You can blacken images, you can darken images, you can whiten images, you can do all sorts of random things. Whiten, essentially, what is it doing? It is adding a constant to every pixel. Do you see what I'm saying? If you add a constant to every pixel, then now, of course, the problem, of course, is 256 is the ceiling, let's say. If the highest you can see as intensity is 256, that's the whitest of the whites. Then if you add too big a constant, it gets clipped at 256. So everything is 256, 256, 256. So you get a nice white screen. That's what happens when you essentially whiten pictures. If you over whiten it, then people are lost. All the structure is lost. If you whiten a little bit, then the structure is still there, right? This is basically how images work. So all I did was I took this noise, multiplied it by some fraction and added it to this to get this. Okay. And similarly, I took this dog, added this bit of noise, I got this. Okay, notice that this is not whitening. This is because in the whitening case, you're adding a constant everywhere. This one is actually noise. That basically means I put different values at different pixels. But when I added 0.01 of that to the school bus, I got this. And when I added 0.01 of that to this, I got this. This should not be surprising because I'm adding very small numbers, right? So your eye should not be able to see a complete change in the object. Agreed? Okay, so the funny thing is that if you ask many neural networks, what is in this, they'll say, 70% probability that it is a 0.7 probability that it is a school bus. What is in this? 0.8 probability that this is a puppy. But what is in this? 97 probability that it is an ostrich. What is in this? Another 97 probability that it's an ostrich. Do you see what I'm saying? Okay. So the question, of course, is, do you see the ostrich here? Do you see the ostrich here? Your neural network does. When it saw the school bus here, you felt good. You kind of patted on the back of the neural network saying, good neural network, you are doing well. Okay, similarly, so when you agreed with the AI system, you're happy. When it makes errors, the question in general in using technology is failure modes are more critical. Because people already look at success mode, right? Look at success modes. So if in fact you would never have, used any technology if it, for example, was not even recognizing objects properly sometimes. You wouldn't have gotten on bridges if they aren't holding up reasonably for some time. But the real problem with technology is, when is this bridge going to fall apart? Do you know what are the times it can fall apart? Like all of you who have done physics, you may have read of these things like, resonance frequencies. Sometimes, the wind frequency might be equal to the natural resonance frequency of a bridge. And so the bridge starts, vibrating bigger and bigger, and the entire bridge just collapses. This happened in the past. This was a time when people thought this is a good bridge, it's looking well, except they didn't consider this possibility that, resonance frequencies can kill this. And so then once they figured it out, they tried to stop that kind of a failure from occurring ever again. Okay, so you do need to understand not just when technologies work, but when they don't work. And here is a classic case where you have no idea why it isn't working. Okay, now the interesting thing here is, let me see if I can remove this. The interesting thing here is, you guys can see this picture. Yeah. So actually, I should remove this. This thing? Let me see if I can do that. Oh, no, it's not that. Okay. No, something happened. Okay. Anyway, for now, I seem to have trouble figuring out how to remove this. Yeah, no, I can remove this. I don't know why it's not working. Okay, let's just clear the remarks. Okay, so now you can see this. So what do you see in that picture? A while back in Norway, it's actually a couple of years back in Norway, people, far right-wing nuts, basically, have put this picture up on Facebook in Norway, and there was a huge amount of worry, basically because they felt that the burqa-clad Muslim women were taking over Norway city buses. You understand what I'm saying? So this was, remember, Norway is our favorite country from where we want immigrants, and they also don't want any immigrants, I think. So there was some far right wing who was basically worried that the country was being taken over by burqa-clad Muslim women, and here is the proof. I'm assuming, first of all, that probably most of you realized what these things are. These are just city bus seats, right? This is how city bus seats look. But if I tell you that some people thought these were burqa-clad Muslim women, you might think, and that they were making these nonsensical, theories, fantastical theories about immigrants taking over their country. You might think that they're bigoted, you might think they're racist, but you can at least understand why they thought these chairs are people with burqas. Do you understand what I'm saying? The point of this is we do have, basically the paradoxes, the visual paradoxes. Sometimes we look at something and misunderstand what it is. From a different light, it looks as like a different object. But more often than not, we can at least explain to ourselves how we made these, mistakes. You understand what I'm saying? So in this picture up front, some of you probably agreed that, yeah, they do look like women, with like a burqa on top of them. Some of you thought, what is Rao talking about? These are just, city bus seats. Why is he making a big deal about it? But having discussed this whole thing, now you can kind of see, yeah, I understand. Okay, even if I didn't see women there, I can see how somebody else might see this picture as that. Agreed? So now that I've told you, this, now I'm telling you, this is an ostrich. You didn't think that it was an ostrich, but now I'm telling you it's an ostrich. Do you agree now? Do you understand now? This is the kind of errors. This error is inexplicable. We have no idea how anybody can make this error. Whereas this, you may not make this error, but you know that somebody might make this error. Do you understand what I'm saying? Machines right now can make these kinds of errors. And that's exactly what he was saying at the end of one of those videos, where he basically, instead of giving either 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 as the inputs, he gave some gobbledygook. He gave just some random noise image. None of us would see an image, a number there. And yet his system, with very high confidence, said, oh, it's 9 or it is 4 or something. Remember that? That's what you need to be really worried about. Do you understand what I'm saying? When you're using technology, it's not when it works, because if it isn't working, you will never use it. It is, do you understand when it fails? Because if you don't understand when it fails, you have no business using it. So if in fact the machine is looking at an ostrich in this particular case, imagine this was an X-ray of your lungs, and Rao comes and adds some imperceptible noise before the doctor basically tries to diagnose what's ailing you. Okay, so I can basically get doctors to diagnose you with any random illness, I want, just by adding noise, which still, I mean, in fact, at least school buses and ostriches look very different. Most X-rays are particularly noisy to begin with. How many of you have seen an X-ray? They don't, most of the time I can't make any sense of them. I mean, that's why you need to get trained. They'll say, as you can see, there are nodules, and the whole thing looks like a nodule to me. There's no separate nodules there. It looks, so given that, it's even easier to say, you add some more noise, it still looks like an X-ray. Except a system trained on these images to figure out what various diseases are will be completely thrown off. This is what we are worried about. People were talking about AI safety, 2 classes back or 1 class back. This is the safety I'm worried about. In fact, you can play this game, where essentially people have played this game. I think I may have it here. Let's see. Yeah, actually, not this one. Yeah, so you can basically, people have made Tesla autopilot misread the road signs. People don't see any difference. So it's like if I go to a stop sign and put like yellow paint on it, police will see it and will put it back into red stop sign. But if I just take a stop sign and make like small changes, just a little paint blotch here and there, which most people can't see, but your Tesla, image recognition system looks at that and says, looks like it's saying go at 85 miles an hour. Do you see what I'm saying? Okay, that is the thing that you sort of need to understand as the limitations of the technology. It's very interesting technology that we have this, but there are all sorts of limitations of this technology, because to some extent, actually, in some sense, I'm going into this before going back to the first part. We are in this wondrous phase. In the video that you guys saw, there were 13,002 weights that he was trying to learn simultaneously. 13,002 weights. Okay, so it's basically, it's a 13,000 variable function. So f of x1 up to x 13,002 equal to, and then it is arbitrary combination of sigmoids and the values of those variables. You guys at best have seen, single variable functions, f of x equal to x squared. Some of you might even have seen f of xy equal to 2x plus 3y squared. Those are the two variable functions. This is a 13,000 variable function. That's what you saw in the 3 brown, 1 blue video. Things like the actual systems that people use, like your cell phone image recognition system, has like millions of these weights that were trained. I don't know, we probably will look at it at some point of time. How many of you have heard of GPT-2-3 systems? I mentioned it in the beginning of the class. So you can look it up, but we can also talk about it later. But GPT-X, which is basically, this is a system for learning to generate language by looking at huge amounts of language beforehand. And it does a pretty good job. So GPT-2 that came like about a year back had 1.5 billion network weights. GPT-3, which is now the state of the art, has 175 billion network weights. 175 billion network weights. At that point, it's great that we can see, oh, it's working. It's kind of making something, it's making some reasonably good English. But what are all the things it can do, such as, in fact, the problem with GPT-3, GPT-2, etc., is something that we'll talk about when we get to bias. Like basically, there are no guarantees. GPT-3, I actually didn't show it here. I have a very nice animation. I may have mentioned it to you guys, that people start giving prompts and GPT-3 kind of completes into an essay. There's this very nice thing that I should show you, where this guy was trying to give a prompt involving two Muslim men. It starts that the prompt is two Muslim men. That's it, okay? And the system will keep on completing it as two Muslim men killed 5 people, two Muslim men. Then he tried to say two Muslim men went to mosque, and then the system says two Muslim men went to the mosque and killed 7 people, okay? It's like the whole damn thing is essentially, it just basically tried to attach Muslim men to killing people. That's not the only thing it does. It's also like, for example, if you say women, it will use the stereotypes about women, men, stereotypes about men. Now, is this because GPT-3 is a mini system? No, it's just channeling what you and I say when we think nobody is looking, which is whole of internet. So what GPT-3 was trained on, just like these guys in the 3 blue 1 brown video, the training data for them was a bunch of handwritten digits and what that digit is supposed to be, right? That was what it is, right? Basically, this he mentioned something called MNIST, if you heard, and it would have things like this. It is 3. and then that is 4, etc. So it actually is telling you label of each of the symbols. Even if those symbols are 4s, can be written in different ways, right? All of these look like 4s. Most of us kind of make sense of them, but they're not really similar at all. They're not identical at all. And yet we think all of them are 4s. Right? And so MNIST told them what the labels are. And so then they trained the system on that. And in GPT-3's case, what it tries to do is it learns to predict the next word given the set of words it has seen till now. And it trains itself to predict next word on the text that is on the web. The text that's on the web includes the Wikipedia text, which typically doesn't keep on going around saying, doing stereotypes because it's carefully curated. Reddit text, 4chan text, all sorts of texts where people essentially, and pick your fake news media text. And so basically they will all be taken and given to this system, because remember, these systems require large amounts of data to train on. The more the text, the better off you are. But then they will pick patterns, and the patterns basically are all our stereotypes. You see what I'm saying? So in some sense, actually, people talking about, will AI systems be biased? Yes, just like we are. And sometimes they can be worse, because there can be some issues in terms of the exacerbating the biases that we already have. But certainly they're learning from the data. It's just like kids, right? I mean, if you keep on using 4-letter words in front of kids, they will learn 4-letter words, okay? If you carefully don't, then they still go to junior high and figure out all the 4 or 5-letter words, because there's a separate training data that's available. Do you see what I'm saying? So anyway, so the point being that in the case of GPT-3, with these many billion parameters, you then basically look at success modes. They think, okay, then there are failure modes. Failure modes don't just have to be school bus becoming ostrich. Failure mode could be, you completing 2 Muslim men into an essay about that's like anti-Islam, or 2 women into a sexist creed. These are all failure modes, unless we are trying to generate systems of that kind. Okay. And then, so because of this, really understanding the failure modes is really a pretty open issue. And that's something that we have to grasp. It's very interesting technology, but it also can fail in ways that we don't quite understand. That is something that already comes out even in this very simple video that you saw, because to look at like 0 to 9 digits, he needed 13,000 weights. Okay, and he made this whole story, Kakamami story, about, I'm pretty sure the reason I'm putting this middle layer nodes is because I'm hoping that they will learn the kind of features that we kind of learn, such as lines, cross lines, etc. But he finds that it learned some random Kakamami thing. Okay, if he just looked at its accuracy was 96%. You're never going to doubt a system which has a 96% accuracy. And yet, basically, it will take, so one of the funniest things is, in general in AI, is one of these things is there's this idea called out of distribution errors. So if I'm trying to get you to figure out these numbers, and I show you, if you didn't know, for example, you know how these numbers are. Suppose it turns out that in Roman numerals, there are different ways of writing numerals, right? So this I'll say is 10, this I'll say is 11, this I'll say is 4. After a while, you'll figure out how to write Roman numerals, right? Then if I show you a banana and ask what is it, you won't say 4, 3, maybe 2, etc. Do you understand what I'm saying? You don't think of banana as part of the distribution of the numbers I was showing you before. But to your eyes, all of these are just images. Okay? And so that's exactly what was happening to this network, because you were thinking that it is recognizing numbers, but it is recognizing patterns in pixels. And so when you thought there was no number and it was just random noise, it just thought, oh, it still is closer to 4 than anything else. Right? And you don't fall for it, because you will basically, we have a much better way of learning things, and we don't exactly know how to do that yet. But this issue of outer distribution, when inputs are not in the distribution that the training data was on, all bets are off. Okay, let's go back actually. So that was actually, I was going to do that as the end part, but we went there first. So that's like a deep dive in the videos that you may have seen. But let me take a minute now and let's bring up any things that you wanted to bring up based on the last two classes. And by the way, I am doing this poll of you guys, and between 70, I mean, of the people who actually take part in the instant poll, between 75, 85% basically say it's great. And then the others basically say, we wish there's more discussion. In fact, some of them are sending messages, which is, I appreciate that. But the discussion is, you have to talk. If only those three people wanted to talk, it's not going to happen. So all of you basically have to talk. And I'm very good at filling the spaces with my voice. So, I will wait. And if the pause becomes too awkward, I'll start teaching you something else. So, let's now unmute yourself and let's, people can bring up things that they want to discuss about last two classes. It could be discussion among you as well as questions. And then a separate thing is I put a bunch of sanity check thing here. It's just a simple question that we can discuss later, but let's start that.
I have a quick question about the legal issues. So because using AI can be used to,
I can't see who is talking now.
sorry, so my internet is really
Oh, okay,
bad.
Marlena, I'm sorry. Okay, I'm sorry. No, that's fine. You told me. That's fine. No, I just was somehow. This is the problem with Google, the Zoom, right? I mean, there is, in general, in actual class, I know which side the voice is coming from. So I can localize. Here, all the voice is coming from exactly the same place. So I just looking at, staring at each of your faces. But yeah, Herlina, please go ahead.
All right, thank you. So yeah, with the problems, like the legal problems, is there any like government regulations on like telling you can do this with AI, you cannot do that with AI, something like
That's a
that?
huge thing. Currently, people are, that's the point, right? I mean, that's basically a lot of different organizations, civic organizations, as well as governments are getting involved in quote unquote putting regulations, but it's not completely clear. So for example, many of you have heard about facial recognition systems. Okay. Remember the ostrich, guys. If you ever want to believe in the technology too much, right, remember the ostrich. Okay, again, when the Facebook or Google tells you, oh, this is you, this is your sister, this is your dad, etc., you're impressed because you never thought computers know how to recognize faces, right? So just the same way, you didn't know that computers can recognize school bus. But now that they're recognizing school bus, then you think that they recognize school buses the way we recognize school buses, because we anthropomorphize everything. That means we think everything is like us. Okay. But if you ever found a human who thinks this is school bus, this is an ostrich, let me know. Okay. And when this can happen, then how sure can you be about facial recognition? When in these numbers 1, 2, 3, etc., up to 90, these numbers, if you give these numbers, the system gives 96% accuracy in the video you saw. But if you give some junk with like a bunch of noise, it says, oh, it's 7 with 99% accuracy. How sure are you about the system's effectiveness? So this is actually behind what happens in this whole facial recognition issue. We will talk a little more about it when we come to the bias discussions, although we are doing it in the background now. So some people are basically, it's like glass is 96% full, glass is 4% empty, and that empty part can basically end the civilization. That's the question, right? You would say facial recognition systems are pretty high accuracy, not for the guy or the woman who got misrecognized and got put in jail, for a long, long time. And remember, all judicial systems, they say, let X guilty go free, not a single innocent be punished, right? The question is, what is X? Some countries, some cultures say, well, X is 10. That means let 10 guilty go free, not a single innocent should be punished. Some civilizations will say 1,000. Let 1,000 guilty go free, not a single innocent be punished, right? And some can go below 1. And it's all basically a cultural assumption about what you are trying to do. And if you are in a system, in a jurisprudence, which presumes your innocence, which thankfully, last I checked, we are all in, right? You do have to be careful about facial recognition systems. And that's why, some cities have actually just outlawed them. Do they not have uses? Of course they have uses. Without facial recognition systems, how are we going to, we're taking billions of pictures every day with our cell phones, and they're all in the cloud, right? Without facial recognition systems, if you want to say, show me all the pictures of my brother with a pencil up his nose, how will you find them? It's very painful to go through each of the pictures. In the old days, we had 4 pictures, we can just look in one of them. There is use, but technology can be used as well as misused. And some high stakes decision making, you should be careful. Okay, and so to Herlina's question, yes, there is interest in making regulations, but just like everything else, I mean, look, all of these are connected, right? Masks, let's not get into that presumably, but masks, some people like it. Some people think, the issue of what is the level percentage of, this business of let's X guilty go free, not a single innocent be punished. You can also think in terms of let X people in good health be inconvenienced. Not a single person should die because of COVID. What is X? Based on the X, you decide whether or not you're for masks. Okay, and so the thing basically is essentially that regulatory work is going on, but there's also pushback from the companies because they would like to use, this technology, for doing lots and lots of things. And you also might want to use this technology, for many good things. Other comments?
Yeah, speaking of high stakes decision making, I know the Department of Justice uses an AI system to for like sentencing recommendation, and it tends to be kind of lopsided when it comes to race and giving out punishment.
So you're saying you don't think Department of Justice uses sentencing recommendation systems, and yet it is lopsided, right? That's what you're saying.
I'm saying that they use recommendation systems, and it is lopsided. I know recently there's been a few things that have come out about it, especially like I think Wisconsin specifically, and how often it'll sentence particular groups of people.
Yeah,
To
that's that whole North Point compass issue. Again, that's again a very interesting discussion that one can have about that wasn't even necessarily neural networks, basically any pattern recognition systems. And some people started, I think in Florida originally, they started using the sentencing recommendation system that a company was selling. And the judges, it was only advisory to the judges. Judges don't have to follow its recommendations. But empirical studies have shown that those judges who are mostly following those recommendations, once you start having an advising system, after a while you say, why think myself? Why not just go with what the system says? At least, in fact, if you follow what the system says, then you can always put it on the system. If you come up with your own decision, then actually you can be held liable for malpractice or something. And so this is what was happening. And so it becomes even more of an interesting question as to understanding fairness of systems like this in these kinds of high stakes scenarios. It is very much a big issue. But again, I actually misheard originally, and that also makes sense. Even without these systems, our sentencing is crude, right? Because we are not driven as pure snow, rather pure as driven snow. We basically have our own, each individual judge will have their own biases and they exercise them. The hope is at least different judges are different. So if you at least get the right judge, maybe they're not as biased as this other person. Whereas irrespective of which court you go to, if behind the dais is the North Point compass system, then you're screwed. Right? Because if that system somehow makes a mistake that affects your case, then irrespective of where you go, you will be getting the same system presenting. So in fact, in the case of bias, it's not so much that AI systems are the first times biases came in. It is two issues. One is people always had biases, and at least their biases might cancel out once in a while, sometimes. Whereas AI systems can essentially institutionalize biases, specific biases. And so if you're not careful, you will just not get out of the hole that you dug yourself into. Okay. Yeah.
To build off of that, I think that we're maybe like moving too quickly towards using AI as a system to determine like people's character. Like I know they use it in China to do their like character scoring. They're using the justice system now. And then I heard this NPR interview where they're basically using an AI system for interviews to judge like whether candidates are good enough. And I think when it amplifies these biases that we hold in the society, but then we treat it as some kind of impartial system, it really like ignores the issues that we have. Like it can't even recognize images properly, but we're using it to recognize people's character. So I think maybe we need to slow down a little bit and be more like skeptical of what it's putting out.
Comments? Look, again, I'm trying not to speak up because, again, obviously, I've been thinking about these issues longer than you've been. But other people have anything to say with respect to the?
Yeah, what's the China's IQ or social IQ?
Social IQ, yeah.
It's like a character score, kind of. So like everyone starts off with like a score of 1,000, I'm pretty sure, and then like based off of like actions one does, whether they like get in trouble or whatever, like the way they act in like society, their score will drop. And once you hit like a certain score, I don't want to say like shunned from society, but like there's like certain privileges that you're just unable to access that are like just basic human rights sort of things. So it's like once you go below a score of like, what is it, like a D or however they characterize it, I think it's like below like 600 or whatever, then like you lose basic human rights to some extent. I just looked it up, so I'm like reading about it right now.
Yeah,
I'll put it on the class Wikipedia page later.
It's not just you who needs to follow the rules, otherwise you lose score. It's also who you associate with. So if like your friend doesn't follow the rules, your score can actually go down.
Sent the link in the chat for the Zoom call so that y'all can look at it.
Yeah, so before you even get up to the full human rights violations aspect, there was like a classic story of this guy who, for whatever reason, got blacklisted. And again, remember that it's very nice to be able to have holier than thou attitude, and I'm happy to be in a much better country currently. But US had blacklisting before many of you were born. There was Red Scare, read it up, Joseph McCarthy, okay? And so basically these are all cautionary tales that we need to be, as I think that one of the most beautiful things is like, what is it? The eternal vigilance is the price of freedom. So you essentially have to keep away, keep looking at what's going on around you. So in the case of China, the way you can actually be completely debilitated is that to buy tickets in the high-speed trains, you need an ID. And with that ID, when you put in the ID, then the system pulls in your social, whatever the social credit. Actually, it's not social IQ, sorry, social credit. So social credit is like credit scores. I don't know, any of you have any credit scores? Probably all of you have 0 credit scores because you still haven't, done enough taking loans, paying back loans, etc. So private organizations hold these credit scores. And if your credit score is low, you would be denied loans. This is social credit. And they, in China, for example, based on that, they'll say, well, you are not the kind of guy we want on the high-speed trains. And high-speed trains are like extremely important in China. It's a large country. And so this guy was essentially kind of going on very slow transport for a bunch of time because just there's due to some, some glitch in the system, essentially his social credit went down. But of course, there's this whole entire issue of why should you even have a totalitarian, authoritarian system surveilling the entire population? But the interesting question there actually is we are all, in all the countries, it is becoming easier and easier and easier to do. Even if you, it's like these tools are becoming available. Surveillance, there is this idea of privacy in the public sphere. In the past, you went and you went to some Donald Trump rally or a Joe Biden rally. You didn't expect, other than your friends, that anybody else will know that you have gone there, even though it is outside. But now, you can there are pictures being taken everywhere. There are facial recognition systems everywhere. I will be able to say, so when you were in that rally, I noticed that you are not wearing a mask. Okay. We can do this now. Before it wasn't possible. And again, there are different aspects here. One is it is actually a tool that is accurate, but as conscientious people, we don't want to use it for this purpose. That's one idea. Right? For example, you shoot people, they'll die. Mostly guns work. But we choose not to use them. The other is the technology can be actually inaccurate. And that brings up another layer of complexity in terms of using it. Other comments?
Sort of going off of the issues that we've mentioned, as well as just going back a bit on the video, because I know how it mentioned in the video how like the accuracy was still 96%, but even with that, he had like a little footnote saying state of the art still 99.7%. And also like you could still feed it random noise and it would still have confidence that it's like a 5 or whatever. So I don't know if it's like sort of beyond the scope of what we're discussing here, but like how would you go about fixing the error, like potentially adding more nodes? Because I know, as he said, it was a bit small, but.
So the answer to that is that we don't solve different carefully packaged problems in life. All the problems come at us and we sort of basically, you should realize that banana is not a number, so I shouldn't be recognizing it as a number. Okay, when they say 99.79%, they're saying of the inputs where people intended to write a number, they just have bad handwriting. And then they also labeled what it is that they wanted to write, and or maybe people agreed that that looks like a 4, more like a 4 than like a 9. Did the system agree with that label? That's what that 99.79% is. There are infinite ways of writing handwritten digits. There are even bigger infinite categories of things in the world which are not handwritten digits. All of them look like dots, pixels on an image. That should blow your mind. That's basically the question of what is accuracy versus not. So again, this is the, let's see if I can get there. Yeah, so there are bunches of things that we still don't know how to do. But, for example, as I mentioned, common sense in general, you sort of assume that people may not be able to tell whether this crazy looking number you wrote is a 4 or a 9, but they definitely can tell the difference between a written number, a picture of a number, and a picture of a banana. Do you understand what I'm saying? But if you trained a system just to do numbers, if you start showing it bananas, then it's just trying to say something.
So then the system is just trying to brute force an answer regardless.
It's not brute force. It's just basically saying, well, I have no idea what you're showing me, but of all the things I have, if I'm looking at the entire world only, if I'm looking at the entire world only in terms of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, actually, let me see. Let me tell you another way of looking at this. I don't know why this went away. The heck. Yeah. Is the correct one, right? Yeah. Also, that went away again. Fine. Okay. So here's a way of looking at it, right? Which is this is the universe of images. Universe of images. Not just 1, 2, 3, 4, 5, 9 images. Images of mangoes, images of bananas, images of people's faces, images of lions, images of every damn thing that you look at the world is just an image on the retina. Right? There's a universe of images. This, I just put a big rectangle and said, every image is a point in this rectangle. Okay. And then I put myself 10 categories. So 1, 2, 3, 4, 5, 6, 7, 8. I'm missing one more, I guess, 9. And then 0. Okay. Those are the categories. Every image is going to be closer to one of these points than it is to any other point, very likely. Using some notion of distance. So then you'll say, looks like banana image is sort of, let's say here. Oh yeah, that looks close to 4. Okay, it's not brute force. We do this, by the way. We do this. Like, for example, people do this, to some extent too, because like you will try to understand, suppose somebody is speaking a different language, your first attempt is try to see if they are speaking English with a bad accent. Do you see what I'm saying? Why? Because you know English. And they said something and it sounds close to this word. Oh, you want a dog? Whereas they might be just saying in their language, I'm dying of thirst. And so you give them a dog. What else will you do? You don't know that language. So that language is out of your distribution. Okay. But for you, many things are in distribution, but for a machine, many more things, depending on how much it has been trained, how many different things it has been trained on, many things can be out of distribution. Which is one of the reasons why essentially there is this whole idea I mentioned last time, remember, inference focused versus learning focused approaches to AI. So for example, there are, oh my God, oh, that's me talking. I was thinking one of you guys were talking that had video on it. Okay, so this business of inference versus learning focused methods to AI. Right now we are going through let machines learn everything from scratch. It's as if humans and civilization didn't exist. It's like we just, poof, we went away, leaving behind our Reddit posts, our Google photos, and our whatever noises and voices that have been captured. And the system is trying to figure out humanity. It's interesting. I mean, kind of an interesting scientific question. But would I want it to be done that way? You guys know a lot more about the world than your system does. And you may not necessarily know what makes a 4, but you might know a lot more about the structure of things in this world. There are fruits, there are numbers. Numbers don't become fruits, fruits don't become numbers. Some of this you can provide, right? Right now in AI, outside, first of all, people like you just mostly have heard of database decision making, because that's the thing, that the perception stuff that you've heard a lot about. But even within research, actually, this business of only acting as if everything is tacit knowledge, which means there is nobody out there who can provide any explicit instructions to a program. Everything has to be learned from scratch. That has become sort of the mainstream. And if you do that, then up until the time they come to our level, they can be wrong in many different, our systems can be wrong in many different ways. Okay. Did I mention this name Polanyi in? Okay, so in fact, this Monday, I wound up giving a talk in this conference I went to, that I will send you a link on. This is, I guess, Polanyi, which is basically, and we probably will discuss this at some point of time, this business of explicit versus tacit knowledge, and both are important. I mentioned in the very first class, and it's interesting that in some sense, currently, in fashion is just go everything from scratch, from the data, as if humans and civilization never existed at all. They have nothing to tell us other than crying, whining after the fact that you're wrong. Okay, but that's the thing. So you kind of need to understand both the pretty amazing things you can do and the downsides that they have. Other comments?
I've been kind of chewing on something that was discussed in the discussion board about AI, I guess, replacing human workforce. And I was kind of wondering, I guess, there'll be a period where people are going to be laid off when they're replaced, but then hopefully in the far future, AI will be more effective so that, maybe humans don't have to I guess work like factory jobs, or I guess and we can just be more creative, I guess, we can just have kind of like a fun world is what I'm thinking. I wish I had like better words to describe it, but
No, I mean, that's a pretty strong question that everybody has about this issue of technological unemployment. And there's no simple answers, honestly. I mean, honestly, today in particular, you should be feeling pretty secure about your job because you sort of figured out that neural networks can't tell the difference between bananas and numbers. And so I think some jobs at least should be quite secure, right? But it's a question of some kinds of jobs. So in a weird way, machines might be good at things that are pretty hard for us, and vice versa. Okay, so for example, reading X-rays is hard for most of us. We somehow think reading handwritten stuff, especially handwritten stuff by Rao, is easy. At least I think so. But reading X-rays is hard. For computers, reading this is just as easy or hard as reading the X-rays. They have no clue what they're doing anyway, to some extent, because all they're doing is they're trying to look at labeled data, and they are essentially training themselves on the humongous amount of these X-rays and the annotated X-rays and the disease that X-ray is showing. And then they're basically able to learn some pattern that they can glom on. And those patterns may not actually mean anything to the humans in the loop. But to some extent, people go to 4 years of med school and then do radiology to be able to look at X-rays. Nobody goes to any school to be able to read handwriting, because that we just get it free upfront. Of course, none of you probably know how to read handwriting. You expect text messages. But there used to be this idea called people can read handwriting, sometime before you were born. And that was easy because we had to do that upfront. So it was something that we all could do, whereas X-rays we couldn't, so we had to go to school. So one of the funny things, actually, the mind-bending things, is it's not completely, there is no clean, I mean, what I would love to say is number of years of schooling. And probability that you will be replaced. Right. Replaced by a machine. Right? Suppose I'm drawing a thing like this, right? I mean, I would like to hope that it's something more like this, right? At least that's what you're hoping. You're going to school. And if in fact, going to school increases the probability of you being replaced by the machine, then what are you doing? Right? But if you're a radiologist, that you're going to school to radiology, you are closer to being potentially replaced. If you are a paralegal, these are basically lawyer support staff, which will look through lots and lots and lots of cases that have been decided before to figure out which are the relevant cases for the case that they are about to argue, and take pieces saying, judge, you said this in 13, this other judge said this in 30 years back. So, clearly you should also say that, because there's constitution, plus there's a whole bunch of cases, and all you're trying to do is trying to show that there was a case that just like yours, which was decided in a way that would have been favorable for you. So the judge should do it that way. And so for that, they have this paralegal staff, which basically go through all these cases, mind-numbing work, and get paid well. Right? That jobs are more easily, at least partially automatable. Whereas plumbers, sorry, they can't be automated yet. Okay, things that you don't pay much, like for example, babysitters, they can't be automated. Some of you have probably done babysitting for lower than minimum wage, which was already low to begin with. That job is going to be free. That job is going to be more secure, honestly, than the radiology job. So I kind of joke that, you guys know Willie Nelson, the country singer, he has this song called Mamas, Don't Make Your Boys Grow Up to Be Cowboys. The kids grow up to be cowboys. So don't let your kids grow up to be radiologists. Right now is the worry, because some of those jobs might go away. But beyond that, it's also the case that it's not really that this is everything in AI is working. In fact, even the things that AI is doing right now, we know that there are problems. But some things, when we have computer supported, there is this idea called computer supported cooperative work. That's what paralegals do. The lawyer sits in there, the main lawyer sits in some room, and then this paralegal staff will figure out a bunch of cases that are relevant and then bring it to the lawyer, and then the lawyer will pick some of them and then use them. So if the paralegal is inexperienced and picks the wrong case, the lawyer would be able to remove that. But they still save time because they didn't have to go through the cases themselves.
Mm-hmm.
Do you see what I'm saying? So you can put computers in these assistive roles where there is still human in the loop. That will still lead to loss of jobs. In fact, the sad part is those are the jobs that were sort of mind-numbing to begin with. Okay, and those are things that might actually be first wave of automatable things. I mean, again, don't believe everything that you read in the news. I mean, essentially AI has become the flavor of the month or the year or the decade right now. And so basically every, especially now that after the elections are over next week, it'll be again back to AI. For the last couple of weeks, I haven't been seeing that many AI articles, but somebody will win and, within a week or a month. And after that, then essentially it'll be back to AI for a while. But that is because they have almost a quota of articles to write about AI, not necessarily because everything is actually equally within reach.
Mm-hmm. I guess based off what you said, how you were talking about, computers just link these two things, they're programmed, oh, this is an X-ray, these are ribs or whatever, if they're a number. There's already a bias of, I guess, within humans that correlation means causation. How do you think computers will be able to sort that? Because it just seems like they do a lot of correlation.
First of all, how many of you know what she just talked about? Okay. It's, by the way, most people in the world completely confound correlation and causation. Okay, let's just first talk about it because I know that some of you raised hands. I'm happy that so many of you know. I'm sort of I think that it bodes well for the future of ASU and future of the workforces that you're joining, but most people don't know the difference, actually. So correlation essentially is these things are appearing together, statistically speaking. That doesn't necessarily mean that, for example, you might have a situation where A and B are appearing together. So if you see A, you expect B to be around 2. If you see B, you expect A to be around 2. Okay, they just happen to be true in the data that you have seen it in your experience. Causation means you have a theory about A is actually causing B, or maybe B is causing A, or maybe C is causing both B and A. How do you tell the difference between causes and correlation? In the case of causation, you can intervene. If you believe A is the one that causes B, if you intervention, if you intervene and stop A from happening, then B also won't happen. Do you understand what I'm saying? So when you have A and B are happening all the time together, and you really, really don't like B, it's not necessary that if you stop A, B won't happen. It could be that, you know, if A is not causing B, B is actually causing A. Or C is causing both A and B. All learning is correlational to start with. Oh my God, I wish there should be an easy way for me to add pages here. Okay. Okay, I'll just clear the pen marks, okay. All learning is correlational until proven otherwise. Tell me some classic examples of correlations that were confounded to be causations.
I know like the classic example is everyone always says more people eat ice cream at the same time that more people are drowning because obviously the heat is higher. But
yeah, no, those are more interesting ones. For example, they also talk about the fact that, what is it? They're beautiful, funny examples of these things, like the number of, what is that thing called? The number of the people, what's the name for the people who rob on the seas, high seas? There's a Pirates. The number of pirates and COVID. It seems to me that number of pirates is inversely correlated with COVID. Right? So if we bring back some pirates, maybe COVID will go away. Is what I'm saying. So if you ignore correlation versus causation, it is true that right now there are very few pirates left. There's a whole bunch of COVID. We don't like COVID. We don't really like pirates also, maybe, but maybe it's coming, Halloween, we can have a few more pirates if we can get out of COVID. So can we just increase the pirates? But those are examples that make sense for people who already realize the distinction between correlation and causation. The problems with correlation and causation occur because we didn't even know this. We don't know what we are doing. Human civilization is full of confusing correlation with causation. Tell me like the most important example. Civilization, I'm not talking about your lifetime. I'm not talking about your parents' lifetime. Who's going around who between Earth and Sun? Oh, you guys know, right? By the way, that's not, like, for the longest time, we believed in geocentric theory. That is, Earth is in the middle and everything is rotating around it. And how can I be wrong? I know in the morning, I saw sun coming up from that side. In the evening, the sun is going down that side. And again, the guy comes up. So clearly sun is going around me. My observational evidence is consistent with basically Earth going around sun, our sun going around Earth. And it's actually Earth going around sun is a much more obvious, sun going around Earth is a much more obvious hypothesis. Because after all, you are there, you don't feel like you are hurtling through the space. Right? So for the longest time, I mean, remember Copernicus, and Copernicus was basically, I think he was sort of thrown out of Catholicism because he basically tried to bring up this heliocentric theory. That is, it's actually the Earth that is going around sun. Okay, to prove one versus the other, you need to do interventions essentially. Human civilizational knowledge is all about causal knowledge. We figured out what causes what. Going from data, you'll only learn correlations first. To convert that into causations, it's much harder. In fact, some of the simplest ideas would be to, like, for example, if you're trying to decide whether runny nose causes some disease or the disease causes runny nose. This is what I'm saying. I mean, if you're in the beginning of the human civilization, runny nose looked like a disease by itself. Okay, so is runny nose causing the disease or disease causing runny nose? You could, for example, give people that disease and see if they will get runny nose. Or you can go around checking, basically, so you need to do experiments. Causal theories require direct or proxy interventional experiments. The easiest thing you can do is learn the correlations. You can just assume that all that machine learning does is learning correlations. In some cases, causation versus correlation doesn't matter as much, because is this becoming the logical concept for, or logical concept for causing this? It's not obvious in the in things like the images. It's not clear whether cat causes cat image or cat image causes cat. There's nothing. It's just essentially, if you see cat image, you want to say cat. But in other cases, you can easily confuse correlation with causation. And that is another huge problem in machine learned systems. And so whoever asked that question, that is a huge open area in AI right now, as to how to get causal models without doing costly and uncivilized experiments. The entire medicine has, in fact, most of the medical research requires IRBs, which is institutional review boards, which will require you to submit what it is that you're trying to do to poor people. Typically, they were poor people, actually financially disadvantaged people, that doctors will have some hypothesis saying, for example, one of the famous ones is the stuttering experiment, where if you keep telling people they're saying it wrong, they're saying it wrong, like many, many, many times, they will start stuttering. Okay, somebody had this theory, they wanted to write a paper on this. So basically, they wanted to check this causal theory. So they got a bunch of people and essentially did this. Oftentimes these would be the disadvantaged people who are already in a prison, or probably, not particularly well off to stop this sort of aggressions. This happened in US. I forget the name of is it Tuskegee study? Something, one of them. I'll check up in a minute and let you know. This is done. This has happened. So, but the point is, that doctor was trying to learn causation rather than just go with correlation, right? Because he is found in many families that people whose parents were constantly criticizing the kids, those kids tended to have more incidents of stuttering. So they wanted to check whether it just was incidental or whether causational. So they went ahead and set up this experiment. So from a science perspective, in fact, this is one of the sad situations, a lot of science came about, especially health science, medicine, came about through unethical means. But they were actually doing scientifically right thing. It's just ethically completely wrong. So the question is, how do you do an experiment without doing the experiment? Do you understand what I'm saying? So this is actually slows down science quite significantly, because you actually need to get these IRB studies approved. So you have to look for naturally occurring scenarios where you can establish precedents as to what happened first, what happened later. And since one other thing, causation travels forward in time. You agree with that, right? Causation always travels forward in time. If A causes B, A can't occur after B. Except in some science fiction novels, future doesn't change the past. So if in fact you happen to have data, transitional data that you picked up where you know the timestamps, sometimes you can use that to show what caused what, rather than just go with correlation. It's a very hot area of research. Now, having said that, let me change the following and say that when people give knowledge to computers, it is often causal. Because we already know what causes what. And we are not going to tell the computer the opposite of what we know already. Whereas learning causal knowledge from data is much harder. You're all totally stuck. I don't understand. I'm not sure whether this is too deep or too boring or too what, I don't know. But it's actually causality, causation versus correlation is one of the most important things. In fact, my students in Intro to AI, this is a 4-level class, senior computer science people. Many times they would put in the feedback that we learned about causation versus correlation. And what a beautiful way Rav explained. On one hand, I'm flattered, but on the other hand, I am scared that these guys made it until senior level, confusing causation versus correlation. That's not a good idea. At least, many of you already know the difference. That's thankfully, but some of you probably figured out a little more now. But I mean, that's one of the most civilizational. This is the whole point. Making systems learn things as if humans and civilization didn't exist essentially means you are saying you figure out the causation. It took us a whole bunch of time to figure out that it wasn't the sun which is going around the earth, even though it's so damn obvious. Sun is kind of going over me every day, and you're saying I shouldn't believe my eyes. And in fact, the opposite is true. And why do you think that if in fact the same sort of data is being fed to the computer, it will take its own sweet time figuring out the causal version, even if we figured out how to actually separate causation from correlation. One place, I know that there's a raised hand, I'm going to get to there in a second. One place where causation and correlation becomes a huge issue is societal issues. right? I mean, is poverty causing crime, crime causing poverty? They may tend to co-occur. Is in our inner cities causing crime, or crime causing inner cities, or something else like governmental neglect caused both? Okay, trying to figure out what is happening from the data is not as easy as you might think it is. And the first things that machine learning systems will learn is correlations. Learning correlations is hard enough to begin with. Okay, yes, there was a raised hand somewhere.
I was just going to ask, and you kind of just touched on it with like the societal issues, like how like an AI mixing up, like what a concrete example of an AI mixing up correlation versus causation would be, and how it would, or like how it would bring about problems specifically.
No, because imagine you have, so credit card fraud. Let me take something little less triggering issue than crime and punishment. Credit card fraud, right? Essentially, you're trying to guess whether a particular transaction is fraudulent or not. Okay, so in a way, basically, you are describing this transaction in terms of some features, such as, it is for this much amount of money, it is being done in this city, it is being done for this particular kind of, the thing that they're trying to buy, the product they're trying to buy. And given all this, I can show you a bunch of transactions that were previously labeled to be normal versus fraudulent transactions. Okay, and then I show you new transactions, and you're supposed to guess whether they're fraudulent or not. You, the system. What you'll be learning is correlation. So what's black while driving? What's you being stopped in certain neighborhoods because you look different? These are all correlations being confused as causations. And if we supposedly civilizationally advanced non-machines are still doing it, you bet that AI is very much capable of doing it at scale. Do you understand what I'm saying? I mean, we are doing this. We've been making fun of AI systems because they can't even tell the difference between bananas and numbers. And yet you guys heard about this Scottsdale character who basically told a bunch of African Americans, how the heck are you here? This is a no an African American zone with that being replaced by N-word. Okay, this is happening. This was, we once in a while we get into national news. This was one of the things for which we got into national news, unfortunately. But this is people doing this, right? So why do you expect machines won't do it? I mean, again, of course, in the case of people, there could actually be, they know better, but they chose to do this way. That I hope is really the case in those particular scenarios. But in many, many cases, people just cannot tell the difference between causation and correlation. It's easy in abstract to say, I know, but most of you in a new area, you don't know what causes what. When you do know what causes what, you better tell that to your system, because it will take a long time for the system to figure that out, just as long as you did. Okay. Causation correlation is bedrock problem in general in human civilization, and also for AI, because you're learning from data, you're going to confuse. Unless you provide additional information about causal models that you happen to know, what causes what. Okay. Other comments?
Just to go back on the point made about like manufacturing being automated, there's a video that I watched where they give a tour of the Tesla factory, and half of it is, you know, automated with large robots, and the other half is, you know, with people. And they'd say the robots are handling, you know, repetitive tasks, and humans are good with adaptive systems. So at what point can we see, or what would have to change for artificial intelligence systems to be adaptive and
They're always adaptive, actually. They are adaptive, but you know, in the sense that getting system to customize to you is what AI systems have become extremely good at. By the way, that's what is filter bubbles. That's why if you are a conservative, you don't know that liberals exist, or you think they're monsters. And if you're a liberal, you think conservatives don't exist, or they're monsters. Because you only get the news. By the way, how many of you have seen, what is that thing called? The Netflix documentary that's actually right now. What's the name? Social
Dilemma.
Social Dilemma. Please watch it. Okay, because that's all about this. Because the systems are essentially learning, you know, to customize to you. Adaptivity is free, you know, with AI systems. Competence is a different issue, but adaptive, you know, customizing the system behavior to you is free. It's a good thing in general, but at mass scale, it's been used to essentially hack us. You know, that's what Social Dilemma says. And that's actually, it's not, you know, much of what happened in that particular, I mean, if you have Netflix, please watch it. You know, it's very relevant because, I mean, even though, I mean, obviously it's a documentary with a particular viewpoint, so it's going to make that be a bigger worry than, and not forget about all the good things that customization does. But, you know, in general, you don't think customization can be a bad thing, right? But customization actually can be a, you know, bad thing in that particular case. And in fact, AI systems are very good at customizing themselves to users if they have data about users' behavior. Okay, now coming back to the manufacturing issue, actually, the interesting issue there is how to make systems collaborate with us. You know, AI systems collaborate with us such that we'll do some things and they'll do something else. And it should be like you're working with other people. That's actually a research area. In fact, turns out to be the research area I am interested in. That's what my group works in. We might talk about it at some point of time. In general, this is connected to the social intelligence aspects. The machines then need to have a sense of what is it that the human is trying to do and try to not get into their way, try to help them, you know, and sometimes they may have to provide explanations as to why they are doing the task the way they are doing. Those things wind up being important. And then, of course, there is also the issue of how many competences actually the factory robot has. That also becomes important. And that is just improvements in robotic technology.
Okay.
Okay, so don't be shy. Tell me how many of you who looked at that 3 blue, 1 brown video couldn't make any sense out of it. Okay. So yeah, that's very reasonable. So one idea is actually you might want to see, I mean, if you have actually questions, I mean, I have some, you know, pictures from there, things like this, I can just quickly go over them, but it's also useful if you might want to go through the videos again. I mean, they're much more fun to watch videos than these lectures or whatever these seminar things, right, that I put up. You know, he has a lot more animations than I do. But I want, that's like the theoretical minimum that you need to understand to make sense of whether the technology you are talking about is actually capable of doing some of these things or not. I mean, what are all, so basically, if you just read the New York Times articles, then you will just say, oh my God, technological unemployment is about to come. Oh my God, bias is about to happen. And you need to understand at least how some of this data-based decision-making works. And so these are like the simplest cases, simplest, fun to watch videos. I didn't realize, I thought they were like 4-minute videos. In my mind, they were 4 minutes videos because, it looks, I can fast forward it. But I actually watched them today, for 42 minutes. In fact, if I thought it was 42 minutes, I would have asked you to just watch one, honestly, because I somehow thought they're like total of 6 minutes, 8 minutes, but they're very good, actually. They're really, the first 2 videos together, honestly, it's almost probably worth, which is what actually was my default idea, that I will play them in front of you, all of us, like whatever, what is this thing called, the watch together, and then I can keep stopping it, and then people can ask questions. That is something I'm willing to do if there is interest, but we can also, those of, if majority of you had a sense of what happened, if you actually go back and look at them, you might see more based on some of the discussions we had. But let me see, since I have like about 20 minutes, let me actually try to say what, I only actually took a couple of screenshots, but let me, go ahead.
I think the chat's exploding with a suggestion. I don't know if you can see it, but.
I can't see chat. You have to chat with me. I have it in somewhere here. So what do you want?
It says, maybe in order to understand the concepts in the video more, we could have some people try to explain to their classmates what they understood, and people can add into it. That way more people can get involved in discussion.
More than happy for that to happen. Then I don't need to say anything. Yeah, so I mean, I can say that whoever, I don't know, so everybody tried to explain to the 2 brave people, who said they may not have completely understood it. And, I can secretly enjoy your explanations. So please do. I think it's a good idea.
I guess I'll start off by just asking a question. I was curious as to how the weights were calculated. Like, I think I just kind of lost a bit of like the progression of logic, where I just realized I was like, wait, where exactly are these weights coming from?
So the weights are essentially, so you ask questions like this, I'll explain. And then you guys will go back and say, Rao didn't let us explain. And that's not good. So you have to pick one. Again, this is the difference between STEM areas and social sciences, where it's not clear that just because I've been thinking about race and, punishment, I know anything more than you do. You may well have a very fresh perspective. Whereas in some of the things like, STEM areas, you have to know some basic facts before you can start having opinions. That's just unfortunately true, right? So what is happening with respect to your question is that if you just assume that these weights, so for example, this neuron here, it's been connected. This thing has been connected to all the initial things. And initially you just randomly initialize these weights. Just pick a number randomly between 0 and 1. Okay. Actually, in fact, it doesn't have to be between 0 and 1. Weights can be bigger numbers. So it can be between like -100 to +100. Okay. And they just initialize them. Okay. Now what happens is you now have a network. So you have a network here where in the first iteration, in the beginning, 0th time, all of these weights have been randomly set. That you can pick, because there are computer programs which you ask, give me a random number between -100 and +100, they would be happy to give you one. Right? Because it's not that hard. First of all, do people understand that you can make random numbers? Right? Okay. So in fact, if you wanted to just pick a random number between 0 and 1, right, then you can toss the coin. I mean, either 0 and 1. Okay, not between 0 and 1, but either 0 or 1, you can toss the coin. Okay, but there are ways in which you can generate a number between -100 and +100. Okay, so that initialization takes microseconds. How many our numbers? I can give you these initialized numbers. Let me just complete. Okay, and once I do this, this is already a network. This is already a network. And so you then give each training example. So this is 2, I put this here. It will, if it shows 2 for it, then there is no error. If it shows 6 for it, there's an error. This error has to be minimized. So the error really is this output is the function of 13,002 variable function. 1302 variable, 13,000, right? 13,000, right? They say 13,002 variables function. It's a huge function, but it's a function. So you put the inputs, then you crunch the numbers, the output comes out. Okay. And that output, if it is what you expected, you're fine. If it's not, there's an error. And that error needs to be minimized. And the error itself will be a function of the weights. Okay. And if you keep changing the weights, the error can change. Now, since the weights are continuous, if it's just a single weight, you may have a function like this. For a single weight, maybe you have a function like this, and then you're trying to decide what is the best value for the weight, and you will realize it is here. To do this, you use basically calculus to figure out the place where the derivative becomes 0, which is what you did for simple functions, because you can take f dash x, equate it to 0, solve the equation. Oftentimes, you can't solve the equation. So instead, what you do is you happen to be in the beginning, you were, let's say, in here. The original weight is here. According to that, the error is this much. Then you essentially take the derivative. And the derivative tells you the direction, the weight. If you change the w this direction, then the function is increasing. So you change the weight the other direction. So you change the weight this direction. How much? A little. Because if you make a big change, you might be here. Right? Because if you make it too big a change from W0, you might come here and then you miss the middle. So essentially what you will be doing is you will be setting weight, you'll be setting W1 is set to W0 minus F dash with respect to W0 weight, because these are multivariable functions, so you need to take partial derivative. That's the idea. So you make a little small nudge to this weight. Remember how many weights you have? 13,000 weights. You are simultaneously changing 13,000 weights a little. If you have 2 things you have to change to get to a good configuration, we screw up. This machine is trying to do it for 13,000 weights. So this idea itself is called gradient descent. And gradient descent is, if you took calculus, then basically gradient descent just means go in the direction that is opposite to the derivative. Derivative for single variable functions will be the slope of the function, slope of the tangent at that point. And you just go opposite direction just a little. And now you have a new set of weights. You then compute the error again and change the weights again based on that, until you come to a point where essentially you have reached a local minima, which means both sides, if you change any more, the error is increasing rather than reducing. Okay, and this is why anybody who says they understand truly what gradient descent is doing for a 13,000 two variable function essentially are lying. Okay, they are like people who look. Do you guys see what this is? This is coral reef. You know, my son was when we were in the barrier reef in Australia. You know, he basically took this picture when he was snorkeling. You know, coral reefs, right? They're these majestic structures. How are they formed? How many of you know how they are formed? You know how to kill them because we're doing a good job of it. All coral reefs are dying right now. You know, but how are they formed?
Lava.
What?
Underground lava.
No. Interesting. So it's not underground lava, no. Neither is it above ground lava. Do you guys know what is the largest living thing in the world?
The coral.
What?
It's the coral reef, the Great Coral Reef.
Alyssa, what were you going to say?
Oh, I was going to say a fungus, actually.
Yeah, coral reef is actually the largest living thing in the world. So it's certainly not lava because lava is not a living thing. Okay, so actually the interesting thing is that the coral, the calcium part of the coral reef, the structure themselves, it's the poop of these little sea creatures. I forgot their name, anemones or something. I forget this name. They just, you know, if you keep pooping in that same place over a deep time, you will have coral reefs. You guys know how Grand Canyon happened, right? I mean, you are in Arizona, you know how Grand Canyon happened. It's the same damn thing. It's not like somebody got a bulldozer and made Grand Canyon. You know, over deep time, very small changes made Grand Canyon. Anybody, I mean, we theoretically understand, yeah, that is possible, but in really saying that this can happen, this can make Grand Canyon is really very hard to grasp. It's the same sort of a thing to me. I mean, you need to have a sense of wonder while knowing in microcosm what you're doing to the weights, which is you're changing 13,000 weights a little at a time. And if you do it often enough, then you are reaching the, sorry, where are we? If you're doing it often enough, then you're reaching the minimum of this 13,000 dimensional function. By the way, you do realize that you can't even visualize more than two-dimensional functions, right? Right, because if you have a function of x and y, then the value of the function is z, that is 3 dimensions already. You don't actually have any sense how to visualize high dimensions beyond 3. If you do, you know, great, because you will do extremely well, because the rest of the humanity sucks at high dimensional functions. Okay, so in this high dimensional space, you are doing, the beauty of math is it works across. How many other dimensions it works? You know, if it is 1 dimension, it is slope. In 2 dimensions, it's partial derivatives. From 2 dimensions to 10 million dimensions, a gradient is a vector. It's just the derivative, it's a vector of all the derivatives in all the dimensions, partial derivatives in all the dimensions. How many of you have done partial derivatives in high school? Okay, I know that it will reduce the numbers, obviously. I realize that this is a, you know, a set of other, we're not just math people here. But if you remember partial derivatives, it's just that. Okay, and you are essentially doing these little movements as dictated by the partial derivatives, and voila, one day you might reach a minimum. Now, the sad part is it doesn't have to be any global minimum, because you might have a function like this, where the minimum error is here, but if I am here and I do gradient descent my way, I will reach here. And I feel good. Do you see what I'm saying? Because I basically have reduced from here. If I change weight in either direction, the error is increasing. So I think I have reached a minimum. But I might only be in a local minimum. And this is one-dimensional case. Single variable case, rather. Not one-dimensional, it's a two-dimensional case. It's a single variable case. You have to do it. Basically, this is happening in 13,000 dimensions for that little network. And for GPT-3, it is happening in 1.7 billion, and GPT-3 is happening 175 billion weights being changed at the same time. But they're being changed with no brain, right? Little, it's like Barrier Reef was basically made, as I said, Barrier Reef was made by the poop of these things. All you needed is time. We can speed up time. Not in real time, but for computers, right? For example, the number of times you update weights can be increased quite significantly if you have powerful GPUs. This was the whole point of GPUs, because every little change that you're doing is essentially this kind of a change, weights being reduced by a little. This is not, rocket science. So you don't need an entire iMac to do this. You just need like a little GPU, CPU. But many of these have to be done in parallel, humongous number of times. And so you are speeding up Grand Canyon formation. You're speeding up coral reef formation. Unfortunately, we don't know how to do it for Grand Canyon and coral reef. We are actually good at destroying them faster than making them faster. But for the computational things in this, in the function space, etc., what you're doing is you're speeding up time. And deep time is hard to understand, which is why nobody believes, quote unquote, that evolution is a thing, right? Because it's so much easier to make up these cockamamie stories that your favorite god or spaghetti monster decided to make everything happen, rather than believe rather than actually admit that blind evolution can make people who are silly enough to take classes during COVID time. They not only make these little creatures, they also make you. The same process, completely undirected process. It's hard to believe, which is why most people somehow don't think evolution is a thing. It's the same thing for coral reefs. It's the same thing for gradient descent. The math is there, but as to how to, first of all, realizing that it actually can happen isn't intuitively easy for you to grasp. But we do a lot of things that are not intuitively easy for us to grasp. That's civilization for us to some extent. By the way, I can't resist. You guys, so if you have an apple can be thought of as a sphere, right? You have bought a peeler on Amazon, okay? So you have an apple and you have a peeler from Amazon, you peeled it. Epsilon thickness peel has gone. So imagine that it's a perfectly spherical apple. So it was a radius R sphere. Epsilon thickness is gone. How much apple is left? This is not calculus, right? If you kind of remember that volume of an apple is r cube. It's 4 by 3 pi r cube, if you assume it is a perfect sphere. Agreed, right? So originally it's 4 by 3 pi r cube. The new apple after the peel is 4 by 3 pi r minus epsilon cube. Epsilon is a really small number. Okay, so what you have left is r minus epsilon by r cube is the fraction of apple that is left after you peeled, right? You basically, when you peel the apple, you think there's a lot of apple still left because only r minus epsilon by r cube is left. If you are eating a 10,000 dimensional apple, right? I mean, instead of a 3-dimensional sphere, think in terms of 4-dimensional sphere. If you can see it, I'm very impressed. But think of a 10,000 dimensional sphere. Math still works. So it turns out that for a 10,000 dimensional sphere, r minus epsilon by r power 10,000. For 3 dimensions, it's r cube. For 10,000 dimension, will be r power 10,000 will be the volume. Okay, and so after you peel epsilon from your 10,000 dimensional apple, what is left is r minus epsilon by r power 10,000. How much will that be? This is, by the way, this is requires some math intuitions, and I know that some of you are mad at me that I'm not doing biases, but the STEM-oriented people who came into this class only knowing calculus, they better understand societal issues. And those of you who came into this class only thinking about societal issues, better understand a little math. That's a fair game, right? So what is r minus epsilon by r power 10,000? Anybody?
Zero.
Zero. Why? Because r minus epsilon by r will be less than 1. Any number less than 1 exponentiated multiple times will become 0. So you can now tonight, impress your friends. And then tomorrow you won't have any more friends, but you can tell them, if you have a 10,000 dimensional apple and you peeled, how much will you be left? 0 volume will be left. A 10,000 dimensional, a high dimensional apple is all peel, no core. Does that make your head, blow a little bit? Right? So we don't have good intuitions about high dimensions. We don't have good intuitions about high dimensions. In fact, let me tell you one last positive thing. It's already 4:05, but this is actually a good news. That look at this picture. This picture is for 2 dimensions, right? Single variable case. Gradient descent, we can get stuck here, can get stuck here. But this is the real global minimum. Imagine as you go from single variable case to 10,000 dimensional case. You can't visualize this, but certainly even this 10,000 dimensional case, there will be local minima as well as global minima. The question is, do we believe that there will be higher chance of getting stuck in local minima or not as bad? And it turns out people don't have good intuitions about it. It turns out that in 3 dimensions, so in 2 dimensions, this is a minimum, right? And anything which looks like this is a minimum. In 3 dimensions, to make it into a minimum, I need to close it in all directions. If I just did like this, it's not a minimum. right? Because it'll come out like this. Do you understand what I'm saying? This is not a valley. It's a hanging ledge in mountaineering terms. Okay, so in 3 dimensions, it's somewhat more work to actually make a little local minimum because you have to close it in all directions. In 10,000 dimensions, it's even more work. Do you see what I'm saying? Which actually means that the dimensions help you. You will have a way of escaping the minimum. The reason you can't escape the minimum here is because if you change this direction or this direction, you are increasing the weight, increasing the error. So you think I'm in a minimum. How can I go anywhere else? Think of gradient descent sort of as water falling. If you pour water, right? Or if you like leave a ball and and by gravity, it will come and stop here. But if on the other hand, in 3 dimensions, if it's not closed, the ball can just come out in the side that is open. In 10,000 dimensions, you may have closed 9,999 dimensions, you the guard of this function, but left one direction unclosed, and the ball knows where to go. It doesn't need to do much of a thinking. Just the gravity will get it out. Where for us, the gravity is the gradient descent. So this is me trying to sort of add on top. I mean, I think he does a very good job. What you should do before you forget today's discussion is look at those 2 videos again. And I'm happy to meet with you separately. Those of you who want to actually understand, at least at that video level, I'm happy to meet with you and go over, we can watch, group watch the video, for example. But I think you need to understand at that level to some extent. But what I'm adding on top is this idea that some really cute things that go on when you start having high dimensions. And we don't have good intuitions about high dimensions. And we are using this technology. Okay, it's not that the small steps don't make sense. The small steps, gradient descent is never wrong. It's the question of whether you got stuck in local minima or not winds up becoming important. Okay, so I think we are like way out of time. Unless somebody wants to add something, I will let you go. But this class should stay in the back of your head to some extent in understanding how this technology is going to change things. You cannot just have, how is deep learning going to change health without knowing what deep learning is at least some level. And it turns out, unlike quantum mechanics, it's not that hard to understand what's going on here if you have some background in calculus, some beginning background in calculus. But those of you who don't, you still actually have some sense that it looks like making little steps, like the way people climb up the hill. If they don't know where the top of the hill is, they'll try to climb up in the direction that seems to increase their elevation. That's exactly what gradient descent or gradient ascent is doing. The gradient ascent is the opposite of gradient descent. So in fact, the gradient descent is a class of algorithm called hill climbing algorithms. Computer science has this idea called hill climbing algorithms, where you make a step that temporarily increases the goodness of your current position. And we understand that that doesn't normally give you global max minimum, because sometimes you have to actually go down, such as you have to go through school, which is probably not fun, instead of making millions of dollars in stock market, to make millions of dollars in stock market. At least that's what I believe. But something like that is what you're doing, which is you are basically making strategic decisions of having less of a salary right now, maybe zero salary, to increase the chance that you'll have a lot more salary later on. The guys who do hill climbing essentially probably dropped out of elementary school and are making some money somewhere. And they have reached some level of local minimum or local maximum, and they're happy there. Yes, sir.
So I just had a quick question with the weights. So when you have all the weights dialed in and you found the minimum, is that what they mean when they say the model has reached convergence, or the model has converged?
Yeah, basically it got trained, it reached convergence. That's exactly what they mean. In fact, really most of the time, converge essentially just means that you at least found a local minimum, or your cloud budget is over. GPU cloud budget is over. So you say to your boss, that's it, man, this is it. This is the best set of weights I found till now.
Thank you.
I mean, it's at once very easy to understand and mind-boggling that this is as effective as it has become. Again, if you go back and hear what I was saying in the first class about what happened when, why neural networks came 3 times during the history, it's because in the first few times, the deep time was we are not able to speed it up fast enough. And to speed up the deep time for neural networks, you need lots of examples, because every example will give you error. And lots of times you go down the minor changes to the weights until you reach the local minimum. One is amount of data, one is the speed, parallelized speed of how many steps you can make. And both together wound up making us use this data right now. Do this thing, because the data got available because of the internet, etc., and the GPUs were just compute. Okay. So think about this in the background, and people who had questions about those videos, please get in touch with me. I can even make a separate time. We can go over them. I'm happy to do that. And you can also look at it again. And then next class, we'll go back to happy things like bias in society, etc., which is fun, lot more fun to talk about than high dimensional apples. Although high dimensional apples, which are only all peel and no core, is just as much fun, really, at least for like a cocktail party game. Okay. Have a good weekend, guys. Thanks.
Thank you.
Thanks.
Thank you.
Thank you.
Thank you.
Thank you.